Okay, so today we continue solving quadratic equations. So far we have learned two different ways to solve quadratic equations. What was the first way? Well, by the way, everybody that's here took the test already last week, right? Yeah. So, what was the first way that we learned to solve quadratic equations? What was the first method that we learned for solving quadratic equations? Yes, Louis. So, Adrian? Factoring, sure, that was part of the test last week. Then yesterday we learned another way, and that was called? Yeah, square root property. But the thing is, both of those options are limited in their own way. If we ever get into learning about different types of solutions, which we should, factoring is limited because factoring will only allow you to find solutions if those solutions happen to be rational. It's easier to find rational solutions when your ears are warm. But if your ears are not warm, then you can't find them. Can you just take the hood off, man? You have nice looking ears, man. It's a really nice shape. Just be free. Just be free. Let it go. There you go. Square root property, what we did yesterday, is limited because that only works if you only have the x that's being squared. If you have an extra x in there, that's not going to work. But now, these next two methods, today and tomorrow, are much more thorough. The thing is, tomorrow, the quadratic formula basically does all of this work. All the work that we're going to go over today, or the 90% of it, is already taken into account in quadratic formula. Quadratic formula was derived from completing the square. And if you ever have enough time and you're not too bored, I'll even show you the way that quadratic formula was derived. But this is what kind of came before quadratic formula, and it's pretty extensive. So, anywho, the whole point of completing the square, okay, the square in completing the square, is that we're trying to get a perfect square trinomial. At least you should know what that is already. Okay, what does a perfect square trinomial look like in factored form? It's a single parentheses with a binomial, two terms on the inside, and the square on the outside. That's what we're trying to acquire. And if we don't already have one, because that's what this pre-check tells you to look for. If you already have it, great. If you don't have a perfect square, and remember the check for perfect square trinomials, first and last term have to be positive. First and last term have to be first and last term positive. First and last term. It has to be positive and negative, yes. First and last term positive. First and last term perfect. And in the middle has to be equal to that b squared. B squared has to be equal to 4ac. But if we don't already have that, now we have to kind of manufacture our own perfect square trinomial. So that's what these steps are they're gonna do for us. We're gonna be able to make our own perfect square trinomial in our easy bake oven. The first step is going to be the same as the first step from yesterday. We're going to get all the terms with a variable and put them on one side, all the constants on the other side. The difference is today we can't have any type of x. It doesn't have to just be the x squares. We can have any type of x. Variables on one side, constants on the other. Okay? Then the second step, you might have to, I might have screwed up here with my arrows. Yeah. Okay. Yeah, this might be a little confusing, but the second step, remember, we're making our own perfect square trinomial. The second step deals with making the first term perfect. Okay? How do you make the first term perfect? If it's already perfect, we can just move on to step 3. So this is how we make the first term perfect. Make it into a perfect square. Step 3 is how we're going to make the third term. We're going to make our own. It's like arts and crafts. Now, here's where I kind of differ a little bit from books. You guys showed from factoring that a lot of you chose to go away from what I was teaching you, and that's fine. And You dug your own grave because a lot of those people that were doing like the X method, it's not like they did any better on the test than other people. But what most books would tell you to do here to make the first term perfect is they would tell you to divide by A. So like I don't know, Ellie, give me a number. Okay, so let's say we had 27x squared was our first term. What's the A there? 27, right? Well, if you were to get any number and divide it by itself, what do you get? You get 1, and 1 happens to be a perfect square. What's the square root of 1? 1. So that works, that always works. You can always, on this first step, instead of multiplying by A, you can always divide by A, but yeah, if I'm going to divide A, I have to divide it everywhere. And if I get two numbers that can't divide, what am I going to get? What am I going to get? A fraction. So on this step, if you choose to divide, just be prepared to deal with fractions. Every book I've ever seen tells you to divide. Okay? Now, luckily, Papa Romero takes care of you, and there is another way, even though it's not shown in books, there is another way that you can get this perfect square at the front, and that's to multiply by A. Give me another number, honey. This time give me a small number. I don't feel like multiplying that big. All right, let's go 5. So let's pretend that my first term was 5x squared. What's A there? If I were to multiply, if I were to divide by 5, yeah, I get 1. 1 is perfect. What happens if I multiply by 5? I get 25, and 25 is a perfect square. Any number times itself has to give you a perfect square. But the difference is because since I'm multiplying and not dividing, I'm not going to deal with fractions. Now, you might get fractions later on, but at the very least, by multiplying here instead of dividing, you are postponing your encounter with the fractions. If you're going to get fractions, you're going to put them off for a few steps, which I'm sure you would appreciate. Okay. Then we move on to making the third term perfect. When you make the third term perfect, okay, this is another formula you probably won't see in books. We're going to use b squared over 4a. This formula always works, but you probably won't see this in books. In books show you b squared, b over 2 squared. When you look on books, that's what they tell you. This only works when a is 1. Remember how I told you that books tell you to divide on the second step? Meaning you're always going to end up with a 1 in front. But yeah, if you have a 1 in front, b over 2 squared would work. But the one I'm giving you works for any type of perfect, as long as a is perfect. A has to be perfect, but we would have already made a perfect up in this step. By making the first and last term positive and perfect, and by using this specific formula, that is going to now guarantee that I have this perfect square trinomial that I wanted. So I can go ahead and factor. I don't have to test anything out. I can go ahead and factor it. And what that perfect square trinomial is going to do now is it's going to give me that single x that I had yesterday. Remember how yesterday we only had one single type of x? And that's going to take us on our time machine back to yesterday. So then now we can just solve by square root property. By having a perfect square trinomial, that allows us to use square root property. It might seem confusing, it might seem boring, but hopefully when I demonstrate it, that's not too much. I hope that if you're still paying attention now, you'll understand more what I'm doing when we get to the examples. Let's solve this by completing the square. What does the first step say to do? Okay, first thing you should do is check to see if you already have a perfect square trinomial. Can this trinomial on the left side be a perfect square trinomial? Why not? 3 is negative, 3 is not perfect, so yeah, can't have it. So now we need to start our steps. What does the first step say to do then, now once we're going to engage in this process? All variables on one side, all constants to the other. That will be more easily accomplished by adding 3. This is very similar to what we did yesterday. The only thing is now on the left, I have But now by doing this is going to now allow me to manufacture my own perfect square trinomial. The second step says to check to see if A is a perfect square. Right now, what number is in the A position? 1. Is 1 a perfect square? Yeah, so guess what? I don't have to worry about step 2. Because this step 2 that I gave you was where we make the first term perfect. The first term already is perfect. How can we make the last term perfect? Well, if A is 1, you could use this and just do B divided by 2 squared. But if instead of having to learn 2 different formulas, if you just want to learn one formula, this formula here always works. That's why I gave it to you. We can just do B squared over 4A. What number is in the B position here? So this would be 6, don't forget the square, 6 squared over 4A. A was 1. So we're going to get then 36 over 4, which gives us 9. So it is said that that number 9 completes the square. What do we do with a completed square? What are we going to do with that new number that we just got? Add it to both sides. We're going to get that number and add it to both sides. So I'll even help you out for this first one. We're going to color code it so that if you're kind of half paying attention, maybe it'll still somehow register. I'm going to take what I had before, and I'm going to get that completed square, and I'm going to add it to the left side. And then I'm going to take, this is one very common mistake. So I warned you about common mistakes before for factoring, and in many cases people still made them. Like for instance, ignoring the fact that when A is not 1, you have to make those extra steps. People didn't do that on the test. I'm giving you common mistakes here. I can actually get people to do this, and they remember to add it on the left. They forget that they also have to add it on the right, add it to both sides. On the left side, I am now guaranteed a perfect square trinomial. I do not have to test for it. I am guaranteed it, so I can go ahead and factor it. I'm going to have 1 parentheses with a square on the outside. You might remember this. Even though this didn't show up on the last test, you'll be at an advantage because I introduced this to you already. We borrow the sign from the middle, and then we take just both perfect squares and we put them on each side. The sign in the middle was positive. What is the square root of x squared? This x. What is the square root of 9? What is 3 plus 9? And now we get into our time machine because now we're back to yesterday. If I would have given you this equation yesterday, you should know how to solve it. If x plus 3 squared is equal to 12, what would we do next? We would square root. But then now here's where it comes a little bit different than yesterday. The steps are the same, but the numbers are not going to be as friendly. The square root is going to cancel the square, so I have the x plus 3 that I wanted. We learned square root property yesterday, which means I have to put a plus or minus. But the thing is, yesterday, on the homework, I noticed on the written homework, it wasn't as nice. But on the examples, this number always ended up being perfect. But now it's not. Okay, so what do we do when there's not a perfect square there? We've done it before. We've never done a factor tree here before? See what comes out. If nothing comes out, then you leave it. So let's put 12 into a factor tree. Bring out our 2. Do I have enough to bring anything out? Can I bring any of those prime factors out? What can I bring out? What can I bring out? A 2, what's going to stay on the inside? What's going to stay on the inside? 3. Okay, well, you might have noticed yesterday I said, hey, has the variable been solved for? Is the variable by itself already? No. Is the plus minus there? So when the plus or minus shows up and the variable hasn't been solved for yet, what did we do yesterday? We split it. And you can still do that if you want to. But if you're really paying attention right now, if you're not, this is no math involved, this is just listening. In this case, you don't have to split it. Save yourself some work. Because when the plus or minus shows up, if I cannot completely get rid of the square root, I am not going to be able to add. I am not going to be able to subtract anything. So it's almost a waste of time. Do it if you want, and it works, but you're not going to gain anything out of it. Like, I'll even show you on this first one. Watch. If I were to do x plus 3 equals positive 2 square root of 3, my next step is to minus 3. I can't subtract those. They're not like, one has a square root and one doesn't. So I'm just going to end up with x equals negative 3 plus. Normally we write the radical second. So the negative 3 would come first, plus 2 square root of 3. So what I'm just saying to do is, if you can recognize that that square root stayed behind, just do minus 3 minus 3. Write the x equals, and then just write negative 3 plus or minus 2 square root of 3. How many solutions are there? No, how many solutions are there? 2. If you see a plus or minus, it's 2 different solutions. One is negative 3 plus, and please don't tell me, the different solutions are not negative 3 and 2 square root of 3. The different solutions are negative 3 plus 2 square root of 3, which would give me some decimal, and the other solution would be negative 3 minus 2 square root of 3. But those are 2 distinct solutions. They're just irrational. It's a decimal that will go on forever. So, we will write a solution set because those are 2 different. Good job, Alphaz. Green, buddy. What should we do first? Not necessarily. Check. Hey, maybe we get lucky. Maybe we already have a perfect square trinomial. You never know. Could are the first and last term positive and perfect on the left side? Yeah. I know that we don't have it equal to 0, but this step does not require us to have it equal to 0. Does not need to be equal to 0. So my first and last term are positive and perfect. So we can do that little check that we did before. Because right now I'm not guaranteed a perfect square trinomial. I'm still checking. And that check was b squared would have to be equal to 4ac. What's the b here? Negative 30 squared would have to be equal to 4 times 1 times 225. Negative 30 squared is positive 900. 4 times 225 is positive 900. Will you look at that? I just saved myself a lot of work. I already have a perfect square trinomial. Meaning I do not need to complete the square. So now I can factor that perfect square trinomial. It's going to be 1 parentheses with a square. But now this is not going to be equal to 0. What's it going to be equal to? 400. Okay. Borrow the sign from the middle. So what sign is going to be in the middle of the parentheses? Minus. What's the square root of x squared? What's the square root of 225? And now we take it back to yesterday. And now this one's going to look a lot more like yesterday because my next step is to take a square root. If you understood yesterday. And here I get lucky because 400 is a perfect square. What's the square root of 400? Plus or minus 20. Has the variable been isolated? No. But there's a plus minus there. Did the radical stay behind? No. So here let's split it. X minus 15 is equal to positive 20. X minus 15 is equal to negative 20. Plus 15 plus 15. X equals 35. Plus 15 plus 15. X equals negative 5. So those two numbers that make this true alphas. One is 35 and one is negative 5. If If you want to sleep, I can give that desk to somebody. There's a packed class, and I think some people back there want to sit closer, so just let me know. Make like a sleeping section. Bryce, how you doing with this? Any questions? If you do, holla with an A. It's like holla. No. Sure, nobody? All right. This next one. Let's solve by completing the square. First step. Can this possibly be a perfect square trinomial? No, why not? 3 is not perfect, so let's not even waste our time. Let's commence the process. What am I going to do next? Yeah, let's get rid of that 3 then. Didn't do me any favors, so you got to go. You're fired. Okay. And then, well, not yet. First, you got to check and make sure that A is perfect. And it actually is. Because if not, then we have to make it perfect by that whole controversial, do you multiply, do you divide type of deal. But we don't have to worry about it because A is perfect, it's 1. So then, yes, we will complete the square. The formula that always works for completing the square is the one that I gave you, which says B squared over 4A. That's going to complete the square. So, let me think. That's going to be 25 over 4. Uh-oh. Can I divide 25 over 4? No, sadly it's a fraction, but there's nothing we can do about it because that's the number that happens to complete the square. You gotta stick with it. What do we do with that completed square? What do we do with a completed square? Add it to both sides. Good. I will not color code it for you this time, so hopefully you're paying attention. X squared plus 25x plus the 25 over 4 equals negative 3 plus 25 over 4. You gotta add it to both sides. Now, if there is any good news, it's that by completing the square, I am now guaranteed a perfect square trinomial. Look, Ma, I made it with my own hands. My very own little perfect square trinomial to call my own. So I will have a parentheses with a square. I'll worry about that right side later. Hopefully we don't have to add fractions. Borrow the sign from the middle. What's the middle sign? Plus. The first term is the square. What is the square root of x squared? And oh no, I gotta take the square root of a fraction. No. It's not that bad. Just take the square root of each number. Square root of 25 is 5. Square root of 4 is. Okay, but then yes, sadly over here on the right side, we're gonna have to know how to add fractions. I would advise you to write this as over 1 if you need to. What's the LCD of 1 and 4? If I need to make the denominators match to add, Irma, what is the least common denominator of 1 and 4? If I count by ones, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and then I count by fours, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. What's the first number I said twice? It is. Or as the cool kids say, foe. So since the second 4 got to stay as a 4, then the second 25 gets to stay the same too. But the first denominator, the 1, became a 4. It did so by doing times 4. What is negative 3 times 4? It is negative 12. What is negative 3 divided by 1? Negative 3 divided by 1. is negative 3. What's negative 12 divided by 4? Still negative 3. I'll write this one more time. And then I get 13 over 4. And now, believe it or not, this takes it back to what we did yesterday. It's just that the numbers might not be as friendly as they were yesterday. What's going to be the next step? Now that I have a single x, okay, I can just do the square root. And I get x plus 5 over 2 equals, well, the same way like that up here, when I had a fraction, I took the square root of each number. It's the same thing here. Just take the square root of each number. But 13 is prime. So when I take the square root of 13, it stays the square root of 13. What's the square root of 4? 2. And then don't forget square root property says plus or minus. Has the variable been solved for? No. Did the square root stick around though? So splitting is not going to help me. If you want to split this, I must do the same thing every time. Then yeah, go for it. Do it. Split it. It's fine. It's just nothing is going to come from it. So I would just tell you, all right, this is positive, and then let's go negative 5 over 2, negative 5 over 2. Cancels out. So x is going to be equal to, normally they write the radical last, like the plus or minus would come last, so you would write negative 5 over 2 plus or minus square root of 13 over 2. If you leave it like that, it's fine with me. But since I don't write every test and I don't, like the homework, I pick the questions, but I don't like write the answers myself and stuff, you're probably not going to see it that way. Okay, the way that's, because the denominators are the same, you see how they both have a 2 on the bottom? What more than likely you'll see is just a single fraction with a 2 on the bottom, and then they'll move just the negative 5 and plus or minus square root of 13 to the top. That's how Tiffany's seen it before. So if anybody has any questions as to how that looks, just ask Tiffany. She is the authority on square roots. Salim, any questions? No. This is as hard as it'll get. Because tomorrow what you get is basically like you get to start roughly like here. They already have the x by itself. And all you gotta do is just plug in numbers. That's what we get into tomorrow. Okay. Do we have a perfect square trinomial here? Of course not. We don't even have a trinomial. How many terms are on the left side? 2. So we got to begin our first step. What's the first step say to do? Okay, all variables on one side, all constants on the other. That has already been done for us. So that's good. Right, Tiffany? What is the next step? What does step 2 say to do? Let's make A perfect. Every one that we've done so far, A has already been perfect. Is A perfect here? Is that a perfect square? No. So this is where we just find a little controversial step here. I can't do anything to completely protect you from fractions, but if you look in most books, they'll say, okay, A is 3, right? Let's get that 3 and divide everything by 3. Yeah, which will work great there, but what are we going to see everywhere else? Fraction. I don't like. So the other option, if you choose to go my way, is I said, okay, instead of dividing by 3, let's multiply everything. I still have to do it to everything, but at least I can multiply and I can avoid fractions, at least temporarily. 3 times 3 is, which is still perfect. Let's go back to that. Now, the only thing that allows you to do this is that you're using the formula that I gave you as opposed to the one that you cannot use b over 2 squared here. If you're going to do it this way, you have to use b squared, which is negative 12. Because now I already got the first term perfect. Now I got to work on getting the last term perfect. I got to complete the square. So negative 12 squared over 4 times a, which is 36. Oh, a is 9. That's going to give me 36. So I get 144 over 36, and I believe that's 4. Does anybody dispute that? So what number completes the square? The 4. What do I want to do with that 4? Add it to both sides. Tiffany, are you going to tell me this is too hard? So plus 4 on the left, plus 4 on the right. Hang in there, Lana. Adrian, do you want to give Lana any words of encouragement? Like, Lana, you can do it. By completing the square, as long as you did everything correctly beforehand, you have now guaranteed yourself a perfect square trinomial. So we have 1 parentheses with the square. On this side, I can go ahead and add up. I get 10. Let's figure out what goes in the parentheses. Syria, what sign is in the middle? Okay. Irma, what's the square root of 9x squared? Not just x. Huh? 3x, that's good. And then Irma, what's the square root of 4? So far, so good. How many x's do you see now? Just 1, and it says it's inside the parentheses. It's considered to be like the ones we did yesterday. So what's the next step? Square root, sounds good. So I get the 3x minus 2 that I wanted on the inside. 10 is not perfect, but it's also not prime. So you're supposed to do a tree with 10, but if you do a tree with 10, it's just a 2 and a 5. There's no difference. So that's gonna stay the same. But I need to have a plus or minus sign. That's what we did yesterday. I got excited. Has the variable been isolated? No. But was I able to get rid of the square root? Nah. So guess what? The little splitting thing is just not going to help you. You can split if you want to, but you're just going to be writing everything twice for no reason. So I would just tell you to leave it like this. What's the next step going to be? Add 2. Just add 2 to what we have over here. Write the plus or minus second. So 3x is equal to 2 plus or minus square root of 10. What's the last step? 5 by 3. So we get x is equal to 2 plus or minus the square root of 10 over 3. And all the children rejoice because we're done. I haven't been doing it on the last few problems, but we should be writing a solution set because when you have a plus or minus, that means that you have more than one solution. So this should be 2 plus or minus square root of 10 over 3. Louis, how you doing back there? How's the view from there compared to the other corner? That one's better. Are you friends with Harold? You know Harold, do you want to be his friend? I'll put in a good word for you. Do you solemnly swear to be his BFF forever and ever and ever? No questions? Here, why don't you guys do that one? Oh, did we do this one already? Oh, we're doing similar. Okay, you do that one. Raise your hand when you got it. Yes, ma'am. 3 and 1. Okay, it might be. Actually, wait, I can do this in my head. Yes, it should be 3 and 1. Yes. Yeah, should be 3 and 1. Yeah, well, I didn't complete the square in my head. It's just that this one could be done by factoring. I could tell it could be done by factoring. That's why I did it in my head. But we're not doing factoring. Leslie's not going to do factoring either. Leslie, no factoring. No factoring. Okay, what's the first step? Check and see if you have a perfect square trinomial already to save yourself some time, like we have in the second one. Can this already be a perfect square trinomial? ¿Por qué no? It means why not? Why can this not be a perfect square trinomial? 3 is not perfect, yeah. So let's start with our whole move this to this side because it was not easy. It needs to be in timeout. Okay. Is the first term perfect? Yeah, so we're good with that. We have to make the last term perfect though by completing the square. Because a is 1 here, you can use either formula that I gave you. You could use b over 2 squared, but if you just want something to use always, you can always use b squared over 4. That's 16 over 4, which is 4. So the number 4 completes the square. I'm going to add it to the left and then add it to the right. By completing the square, I'm now guaranteed a perfect square trinomial. 1 parentheses with a square, negative 3 plus 4 is 1. Cassandra, what sign is going to be in the middle? It is, because then the middle sign was already negative. Adrian! Yo, Adrian! What's the square root of x squared? Good. And what's the square root of 4? It's not 4. No, the square root of 4 is not 4.
No.
Trick me! And then we take the square root on both sides. And we get lucky because 1 is a perfect square. So we get x minus 2 is equal to, what's the square root of 1? Don't forget the plus or minus. Has the variable been isolated? No. Is the square root still there? No. We got rid of the square root. So let's split it. X minus 2 equals positive 1. X minus 2 equals negative 1. We're saying, like, this is something I would love to spend the second day on. I know I can tell that you would love to spend a second day on this too, but we're not going to. So. Now, everything that can be done by completing the square can be done by quadratic formula, which is tomorrow, and you'll probably find it more convenient. But if the test says to show work and forces you to complete the square, you're going to have to know how to do this. Don't trip, Adrian. Lana is not to be trifled with. Any questions? Here, so we're not going to finish all of these. Let's see if we can find a more fun one. Let's go all the way to the end. See what we can find there. Yeah, that was like much more fun. Ooh. Okay, let's do that one. Find that one there. Find the one that says 2x squared. I like that one. Okay, so we do have a trinomial here, but can this be a perfect square trinomial? Why not? Because 2 is not, yeah, the 2's are positive, but they're not perfect. So let's move this 2 over by doing minus 2 minus 2. And we get 2x squared plus 4x is equal to 6. Then we want to embark on making the first term perfect. which can be done by dividing by 2, but if you want to postpone, I can't completely make you avoid the fractions. It's possible that you're going to have to deal with fractions, but if you want to postpone it as much as possible, instead of dividing by a, multiply by a. So what are we going to multiply by? 2. So get everything and multiply it by 2. 4x squared plus 8x is equal to 12. First term is taken care of. Now let's move on to the last term. That can be made perfect by completing the square. If you're going to do it this way by multiplying, you have to use the formula that was already pre-printed on your notes, which is that b squared, 8 squared over 4a, which a also happens to be 4. This 4 is always there. The first 4 is always there. That gives me 64 over 16. So the number that completes this square is 4. I'm going to get that 4, and I'm going to add it to both sides. By completing the square, I am now guaranteed a perfect square trinomial. Valgrit, what sign am I going to have in the middle? It is going to be positive. Brian, what's going to be the first term in the parentheses? Not just 2, 2x, good. What's going to be the last term in the parentheses? What's going to be the last term in the parentheses? What is the square root of 4? Oh, awesome. So then we square root like we do in the hood. 2x plus 2 is equal to, what's the square root of 16? 12. But don't forget, you need a plus or minus. Has the variable been isolated? No. Did the square root stick around? No, so we should split it. 2x plus 2 equals 4. 2x plus 2 equals negative 4. Minus 2 minus 2. 2x is equal to 2. Divide by 2, divide by 2. X is 1. Minus 2 minus 2. 2x is equal to negative 6. Divide by 2. X is negative 3. All the children rejoiced because we had 2 solutions. One of them was positive, one of them was negative. Golden rays of sunshine. Alfie. Do your friends call you Alfie? Can I call you Alfie? Alright, you guys do that one then. This is the last one. You do it. Do it, do it, do it. You can do it. So long ago. So long ago. ISSAC. What does it spell? Isaac, Isaac. Why not? I put 2 S's, only 1 S. Oh, A's. But it's 2 S's? You have 2 S's? Looks like this spell, right? Here we go again. When does the bell ring for this class? 15. I'll give you like another minute. Come on, Brian, you can do it, Brian. Brian. Nobody? So? What'd you get, Adele? I'm pretty sure one of them should be negative. Let's see. Okay, the first thing, we don't even have a trinomial, so let's not even waste our time with that, but we gotta get the variables on one side. I'm gonna start out doing minus 4x. So I'll get 4x squared minus 4x is equal to 24. Is the first term perfect? Yeah, so guess what? I don't have to worry about the first term, but I gotta make the last term perfect by doing b squared over 4a, and it's gonna be 16 over 16. So the number that completes the square is 1. I'm gonna get that 1 and add it to both sides. 4x squared minus 4x plus 1, and then get 24 plus 1. Here's my PST with the square. What number is going to be in the middle? What sign is going to be in the middle? Negative, so we get 2x, and then we get square root 1 is 1. Square root. So 2x minus 1 is equal to plus or minus 5. Because there's no more square root, I'll split it. So plus 1, 2x is equal to 6 divided by 2. So Adele, you said 3 was one of the solutions. I agree with you. But then now, I get 2x is negative 4. So see, I was right. One of them did end up being negative. It was a 2. So x can be 3, or it can be negative 2. Yes, so, yeah. Higher than that, or that's good? Higher than that? I just added 1 to both sides.